So we've already got, we got Nancy and Marge. Now we're going to add Mary. Mary's my mom's mom, my grandma Mare. So if you buy 3 pullets, you're either going to have no girls, 1 girl, 2 girls, or all 3. Now realize there's another side of the coin to each of these options. If you have no girls, that means you have all boys. If you have 1 girl, that means you have 2 boys. And if you have 2 girls, that means you have 1 boy. If you have 3 girls, that means you have no boys. Hopefully you're getting why this is called the binomial now. Good. Let's, just like we did before, let's do the end caps first, because they are the easiest mathematically to kind of deal with. So let's go with the 3 girls case, because this is what we're interested in, right? We're interested in eggs, so we want as many girls as possible. Conversely, we also don't want roosters because they're noisy, and generally speaking, that's what pisses your neighbors off is the roosters. Not the chickens, but the roosters. So anyway, we're going to get three girls out of 3 pullets. Well, that means we have to be 90% lucky for Nancy. We also have to be 90% lucky for Marge, and we have to be 90% lucky for Mary, which means we're going to be 72.9% lucky. Hope you can see that down there and all the foliage. 72.9%. So there's about a 73% chance. Roughly 75, roughly 3/4. So what this means, just putting a kind of an idea of probability in the back of your head, that's about 3/4. So that means if you were to go into a feed store and buy 3 chicks 4 times, in 3 of those 4 times, you'd get all girls. That means in the other time, you'd get a rooster mixed in somewhere. We'll come back to that. That's above and beyond this particular thing, but I like interpreting probabilities as we go too. Okay, here we go. Let's do this end cap here. In order to get this unlucky, we'd have to get 10% unlucky with Nancy, 10% unlucky with Marge, and also 10% unlucky with Mary. Multiplying all that together, that's a 1 in 1,000 chance that they're all going to be boys. 1 in 1,000. Which effectively means you're probably never going to live to see it. Because what that would mean is, again, interpreting the probability, you'd have to go buy 3 pullets 1,000 times. And then on average, in 1 of those 1,000 purchases of 3 pullets, you're going to get all roosters. I mean, it's just so unlikely as if to never happen. I mean, of course it does happen on average 1 in 1,000 times. But realistically speaking, you're not going to buy 3 pullets 1,000 times. So effectively, you could write this off as not happening. However, if you combine these 2 things, 72.9% and 0.1%, that's 73%. That means the other 27% happen in here. Now that is a fairly large probability, as we just kind of evidenced down here when I was interpreting this with you, right? I said roughly 3 out of 4 times you're going to get all girls if you buy 3 chicks. That means the other 1 out of 4 times you're going to get a rooster somewhere. Now we know it's probably not going to be all roosters. That means it probably is going to be 1 or both of these possibilities. Let's analyze those next. Okay, let's talk about getting 1 girl. 1 girl. So 1 girl means 1 girl and 2 boys. So that means 0.9 for the girl, 0.1 and 0.1. So that's a girl and then a boy and then a boy. Multiplying that together, you get 0.9, 0.09, 0.009. That's a very, very unlikely probability. Not quite as bad as this, but still pretty unlikely. And then real quick, I want to come down to this one and then ignore it for a second and then come back to it. 0.9, 0.9, 0.1, 0.81, 0.081. Okay. Now hopefully looking at those numbers, you can tell they're not right. Because when you add this plus this plus this plus this, you're short some probability. These right here only add to 9%, but they have to add to 27%. So where's the other 18%? I'm going to erase this real quick and we're going to come back to it later. The problem is here. When we did the NCAP probabilities, there's only one way for each of those outcomes to happen. If you get all girls, you get all girls. There's no mixing and matching, that kind of thing. But here, one girl and two boys. Well, let's think about our girls again. By writing it as 0.9, 0.1, 0.1, I made an assumption about that, didn't I? I made an assumption that, who was first? Nancy was the girl, and Marge and Mary were the boys. But that's only one explanation, right? Couldn't it also be that Nancy's a boy, Marge is a girl, and Mary's a boy? That would be another explanation of one girl and two boys. So we could also write this as 0.1, 0.9, and 0.1. And hopefully you're seeing where we're going next with this. It's possible that Mary was the boy, and Marge and Nancy were the girls. So saying this out loud, if we're going to get one girl and therefore two boys, either Nancy's the boy and Marge is the girl and Mary's the girl, or Project 1, Nancy's the boy, Marge is the girl, and Mary's the boy, or Nancy's a boy, Marge is a boy, and Mary's a girl. Whew. Now realize each one of those things is equal to the same numerical quantity. Which means an easier way of writing all this out is just doing 3 times that probability right there, which is the same thing as writing them all out added, but it's just easier. It's going to fit on the board better if we do it this way. Now, we knew that that times that times that was 0.009. Multiplying that by 3 is going to be 0.027, which is still really, really, really small, but at least it correctly indicates the 3 outcomes that we have to deal with. Now, what's cool about this is we now know what the 4th probability has to be, because we know 3 of the 4. This plus this is 73%, plus 2.7% is 75.7%, which means the remainder has to be 24.3%. God, I hope I did my math right. Hey, 243, like our math course. I hope that's right. Let's figure it out now. Now, using the same logic for 2 girls and 1 boy. Either Nancy and Marge are going to be girls and Mary's going to be the boy, or Nancy's a girl, Marge is a boy, and Mary's a girl, or Marge is the boy, and I said Marge, I meant Nancy. Nancy, this is hard to say. Nancy's a boy, and Marge and Mary are girls. And I know that one of these things was equal to 0.081, which means 3 of them, we can do the same thing here, right? 3 of them, yes, is 0.243. I did it right in my head. Whew, that wasn't as easy as it seemed. And now, adding them all up, they're 100%. But more importantly, we fused the ideas of Project 1 and Project 2 together to get the probabilities we needed. That was pretty rad. Okay, next video, we're going to buy 4 pullets, which is the royal family flock from so many years ago. And we're going to see how these coefficients start establishing a pattern. Maybe you've already noticed it, but it's a little early to notice the pattern yet. There's a really cool pattern going on in these coefficients. I think we'll see it in the next example, and if we don't, we'll definitely see it as we go into the homework.